Now in this video we're going to look at diode voltages. The primary thing though that we're going to look at is if we're not dropping the voltage that we want. So a zener diode here, you get zener diodes in certain values. And so there's a wide range of values, but let's say all you got is 5.1 volt or whatnot. So you put it reverse bias. Once current is flowing through it, it builds up about 5.1 volts across it, so you need a higher power supply voltage. And then you can tell other circuitry that 5.1 volts, whatever you need. So let's say that's not high enough. We also have a situation here, rectifier diodes. They tend to have about 0.6 volts that builds up across them when they are passing current. And usually you use them to prevent current from going the wrong way through them. That's rectification. That's why they're called rectifier diodes. But they do build up about 0.6 volts. They're not perfect. They don't conduct perfectly well forward bias. And so they do build up that voltage. And usually you just use a rectifier diode on the positive side of the power supply, and the rest of the circuitry has 0.6 volts less than the power supply voltage. But in any case, let's say we need more than 5.1 volts, and 5.6, 5.7 volts around there will be up perfectly fine. And at higher currents, it'll go up even more. But in any case, you can just put them in series right there. So you got the current limiting resistor, and then the voltage buildup of the rectifier diode and the zener diode, they add up. And so we'll have somewhere around 5.7 volts at the output there. And of course you should actually measure voltages of circuits that you're studying. So right there is the cathode, the gray band to the resistor headed to ground. It's forward bias right now. You can see 10 volts at the power supply, but at this node right here where they connect, we're about 0.6 volts lower. So not quite, but pretty close. Now we have the cathode to the negative rail, so it's still forward bias, the anode right here, and to the resistor. And you can see we built up about 0.6 volts across it. So if you need just 0.6 volts, you could use this as a signal voltage. The zener diode is reverse biased now. The cathode to the positive side of the supply, the anode, so cathode the black stripe, anode to the negative supply. And we will check out the voltage across it. Still with the 10 volt power supply, you can see about 5.1 volts. And finally we have the two diodes in series with the resistor. So no band, the anode to positive, the band there, the cathode to negative, forward bias, and the zener diode is reverse bias, the band, the cathode to positive, the side without a band, the anode to negative right there. And we will see that our point of interest right here is about 5.7 volts, a little bit shy. And there you can see our zener voltage there. So they're just adding up. They're building up. And we can build it up however we want as long as we're using voltages of diodes while they are conducting. So in any case, that's it for the video. Make sure you turn off the multimeter. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have links down in the description. But just watching videos helps out a ton. I appreciate that. Thanks for watching them. I will see ya in the next video.